Here is problem 45 from chapter 27 from OpenStax College Physics. How wide is a single slit that produces its first minimum for 633 nanometer light at an angle of 28 degrees? At what angle will the second minimum be? So let's write down our knowns. So we have a wavelength that's given, that's 633 nanometers, and we're told that its first minimum, so m equals 1, is formed at an angle of 28 degrees. So theta for that first minimum is 28 degrees. The unknown are in part A, we're looking for the width of the single slit, and in part B, now we want to know for m equals 2, theta is question mark. So we're looking for the second, for an angle that the second fringe will be. So let's draw the diagram here so that we remember what exactly it is we're doing. So here we have a single slit, and on a screen we're going to see a diffraction pattern that looks somewhat like this. So this here is the single slit. This would be the first diffraction maximum, first minimum, second maximum, second minimum, and so on. So we can label some of these things. So this is the width W. And we're told that a beam of light that goes to the first minimum, so this is m equals 1. Remember that for diffraction we number the minima, so that's m equals 1, this would be m equals 2, and it's symmetrical on the other side, m equals -1, m equals -2. So for m equals 1, we're given that the angle theta is 28 degrees. And now we're looking for the W, the width of the slit, so we want to solve for that guy. Let's use the equation W sine theta equals m lambda. So in this equation, we know the angle, we know the order of the fringe m, and we also know lambda. So then W is m lambda divided by sine theta. M is 1, lambda is 633 nanometers divided by sine 28. And when we plug in the numbers, we end up with a large W here. So that is 1300 some nanometers, but I can convert this to micrometers and just have 1.35 times 10 to the 6 meters, or 1.35 micrometers. So this is the answer for the first part. Now in the second part, what is going on is that we're looking at m equals 2. M equals 2 is up here, and we want to know the angle that a beam of light makes with the principal axis here. So let's change colors and draw that. So we're looking for this angle theta. I'm going to call it theta 2. So we can use the same equation we had before. W sine theta equals m lambda. We now know W, but we're looking for the angle theta. So this was, I called it theta 2. So theta 2 is inverse sine m lambda divided by W. So that is inverse sine m is 2 now, lambda is still 633 nanometers divided by W, which is 1.35 micrometers, but I want this to be in nanometers, so I have to multiply it by 1,000. And I want it in nanometers because I want these units to cancel out so that we don't have any units inside of a trigonometric function. When we plug in the numbers here, we end up with 69.9 degrees. So the angle that this beam makes with the principal axis here, when the order is m equals 2, the order of the fringe is m equals 2, theta 2 then is 69.9 degrees.